Advanced Algebra 2, Concept 8, Modeling with Quadratic Functions. We're going to go through a lot of information very quickly with this set of notes. So please make sure that you pause the video whenever you need to get down all the notes that you need to. So let's start with modeling with quadratic equations. How to write a quadratic equation. Well, if you are given a point and the vertex, hk, you can use vertex form. If you're given a point and the x-intercepts p and q, you can use intercept form. And then if you're given 3 points, you can write a system of 3 equations and solve for the constants a, b, and c and write the equation in standard form. So let's look at example 1, writing an equation using the vertex and a point. So the graph shows that the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. So you can see that the performer starts at a height of 15 feet. Write an equation of the parabola. The performer lands in a net 90 feet from the cannon. What is the height of the net? So notice we have a point, 0, 15, and the vertex, 50, 35. So let's start with that. What we're going to do is we're going to use the vertex and the point that we're given and plug those values into vertex form of a quadratic equation, because the one thing that we don't know for this particular situation is we don't know the a value. So we'll plug in h and k and an x and y value to find the a value. So 50, 35 is the vertex, so that's h and k, and I like to label them. 0, 15 is just another point on the parabola, and that we can plug in for x and y. So into vertex form, we'll get 15 equals a times 0 minus 50 squared plus 35. So let's subtract 35. We'll square negative 50, which is 2,500, divide and simplify. Now, it does end up with an even decimal, so I go ahead and write it as a decimal. So negative 8 thousandths. If the decimal were not even, I would leave it in fraction form because I wouldn't want to estimate. All right, so now what we want to do is that answer the second question. What is the height of the net? Oh no, I'm sorry. Now we need to write, plug in the a value into vertex form, and we're going to plug in the vertex h and k to actually write the equation. So plug the a value and h and k into vertex form to write the equation. So for this situation, y equals negative 8 thousandths times x minus 50 squared plus 35. Now we can answer the question that was asked. So what's the height of the net when the performer lands in a net 90 feet from the cannon? So looking for the height of the net, what we're going to do is plug in 90 for x. And then that will give you the y value, or the height, that pairs with a distance of 90 feet out. So doing that math, you'll get approximately 22.2 feet. And if you look back on your graph, that point, 22.2, 90, or sorry, it would be the other way around, 90, 22.2, is about right. Example 2. So now we're going to write an equation of quadratic using a point and the x-intercepts. So look at this situation. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. So write a function f that models the temperature over time. What is the coldest temperature? So you can see that this data creates a parabola, and that we have 2 x-intercepts at 4 and 24, and then a third point at 0, 9.6. So the first thing we want to do is to use the x-intercepts, p and q, we'll call them, and the point x and y, and plug those values into intercept form of a quadratic to find the a value that goes with this particular situation. So here is our intercepts, And here's our point. So we have P and Q, X and Y. And so now let's plug this into intercept form. So 9.6 equals A times 0 minus 4 times 0 minus 24. So on the right we have A times 96 divided by 96. So our A value is a tenth. Now we'll plug in A and our two intercepts into intercept form, leaving X and Y in general terms to write the equation of this situation. So y will equal 1/10 times x minus 4 times x minus 24. There, we've done it. We've written a function, an equation to model the situation. Now, what is the coldest temperature? So that's going to be the minimum temperature. So we're concerned with the vertex. Now, the x value of the vertex will tell us how many hours after midnight this coldest temperature occurs. So let's find the x value. So 14 hours after midnight, and then we'll plug in 14 for x and find out what the coldest temperature is. It's negative 10 degrees, and remember that we are in Celsius. All right, now let's look at B. Here's something else that we can talk about with this quadratic. This question says, what's the average rate of change in temperature over the interval in which the temperature is decreasing and which it is increasing? So notice that the graph falls from 0 all the way to 14 hours after midnight. So if we draw a line through that, and we're going to find the slope of that line, that will give us the average change in temperature. So I'm using the points 0, 9.6, because that's where we started, and all the way 14 hours down to negative 10 Celsius. So as you can see at the bottom of the screen, I found the slope. 9.6 minus a negative 10 over 0 minus 14 will give us an average change of negative 1.4 degrees Celsius per hour. Now let's look as the temperature increases. So that's 14 hours after midnight up to 24 hours. So we'll find the slope, negative 10 minus 0, 14 minus 24, and that will give us an average change of positive 1 degree per hour, 1 degree Celsius per hour increasing. So which one is faster? Well, the temperature dropped more quickly than it increased. So that's a little information that you can find out from a quadratic. Let's talk about writing equations to model data. So when data have equally spaced inputs, you can analyze patterns in the difference of the outputs to determine what type of function can be used to model the data. Linear data have constant first differences. Quadratic data have constant second differences. That's a degree 2 equation. The first and second differences of f of x are shown below. Actually, let's do them. So notice first of all with the inputs is that those are equally spaced. Negative 3, negative 2, negative 1, each of them is increasing by 1. So now let's look at the difference from one input to the next. So the difference between 4 and 9 is a negative 5, and between 1 and 4 is a negative 3. Between 0 and 1 is negative 1, 1, 3, and 5. So you take the output that's in the front and subtract the one that comes before. So notice we call these the first differences between the outputs, and they are not constant. So this does not indicate a linear relationship. But let's look at the differences of the differences, or the second differences. So take the difference in front, negative 3, and subtract a negative 5, which gives you 2. And another difference of 2, and 2, and 2, and 2. So for our second differences, these are constant. This indicates a degree 2 or quadratic relationship. We could continue if they were not constant and we looked at third differences and those were consistent, then that would be a degree 3. This is a method called finite differences, finding the finite differences. Remember, your inputs need to be equally spaced in order to compare the difference from one output to the next. Now let's look at this in a context. So here we have a situation, some data from NASA. NASA can create a weightless environment by flying a plane in a parabolic path. The table shows the height in feet of a plane so many seconds after starting the flight path. After about 28.8 seconds, passengers begin to experience a weightless environment. Write and evaluate the function. Well, first of all, we think it's a quadratic, but let's just check. So let's do first differences first. So I'm taking the difference of the input between the input in front minus the one behind, and now I'm going to find second differences. And so each time we will get negative 550. So this is very exact data. Real life data won't always be exact. It'll hover around just a common. So I know that because my second differences are consistent, that I have a quadratic situation. So the first thing you want to do when you have a table of data and it says write a function is look at those finite differences. So we're going to write a quadratic. Now the method that we're going to use is using 3 points, because notice we don't know that we have the vertex, we don't see any x-intercepts, so we can choose 3 points. What we'll do is that we'll use those 3 points, the x and y from each of those points, and we'll plug them into standard form and we'll create a 3-variable, 3-equation system. And so that's step 3. You're going to solve the system for A, B, and C, and then write the quadratic using those values in standard form. So let's do that. And we're going to look at step 2. So step 2, I have chosen 3 points that are spread throughout my data set. Now these are my x and y, so I'm going to plug them into standard form. All right, so it's going to look like, in the first equation, a times 10 squared plus b times 10 plus my c value equals my y. So notice how you're plugging in your x values and your y values rather than a, b, and c. Now let's clean those up. So in the first equation, we're going to square, so we get 100a plus 10b plus c equals 26,900. 400a plus 20b plus c equals 30,600, and then 900a plus 30b plus c equals 32,100. Now we're going to use the method where we combine the first and the second equation and then the second and third. We're going to solve using elimination. So I'm going to combine my first and my second, and then I'm eliminating my c's, so I'm going to subtract. So when I subtract, I get negative 300a minus 10b equals negative 3,700. Now I'm going to combine my second and third and subtract again to eliminate my c's. So I'll get negative 500a minus 10b equals 1,500. Now I'm going to combine these two variable equations. I notice that my b terms are exactly the same, so all I need to do is then subtract. So I'll end up with 200a equals negative 2,200, and a equals negative 11. Now I stay in that same system, and I choose the first equation. I plug in negative 11 for a, and I solve for b. So b will equal 700. Now I can solve for c. I'm going to just pick one of my original equations. I'm going to pick the first one and plug in negative 11 for a and 700 for b and solve for c. So when I subtract those values over, c is 21,000. Now we have our values for us to write our equation in standard form. So height in terms of time is negative 11t squared plus 700t plus 21,000. Now, if you remember, the question asked you is to find the height that weightlessness occurred. That was after 20.8 seconds. So we just need to now take our equation that we just wrote and plug in 20.8 for t. So when you do the math, you'll find out that the height is at about 30,801 feet is when people start to feel the weightlessness. This concludes the Concept 8 Part 1 notes. In Part 2, we're going to look at how technology can help us write quadratic equations. So you've learned how to write a quadratic equation using vertex and a point, using the x-intercepts and a point, and then using 3 points to write a system and solve for your constants a, b, and c.